So good afternoon, everyone. Today, due to personal circumstance, I'll be delivering the lecture in a record online format. This session focusing on window design, particularly its functional and performance aspect. So I encourage you to watch this lecture in full. Please note that all of the material covered today will be included in the final exam. So in today's lecture, we'll cover the type and the function of glass, as well as the key consideration in exterior cladding design. The lecture will be concise and compact, please focusing on essential concepts. So let's see the grading type in the cladding system. So let's talk about the material as glass. We talk about the different material, the glass material type from 3460 class. You know about the different the glass option and how you apply the adapter using the different architecture project. So please review 3460 class one more time and just kind of checking the possible the glass material and window glass material type, and please consider to using the one of this glass type for your studio project. So as you know about the glass is most popular the cladding material in high-rise building because of it has a strength, lightweight, durability, and transparent quality. You can design aesthetic facade using this modular system, and this is a Greenland building in Beijing, designed by SOM. It has completed a 55-story tower with an exterior glass module panel. The tower striking facade pattern consisting of special module as prism, catching daylight and recreate with the interplay of light and shadow. When you see from the project, even this part and this part having a different refractiveness. So mean they actually refracting a different way. So also the refracting the different part can reflect in the bottom, reflecting the some sky. That's why the form and design the making a more volumetric facade. Even intentionally to make it a this prism shape, you see that this shade here, to making this shade also generating the 2.5 dimensional facade design rather than 2-dimensional facade. Even when you're comparing to these two buildings, this building looks more volumetric compared to this typical cladding curtain system. Therefore, you have to be consider how you designing about the cladding system, how you designing curtain system. Sometimes rather than just designing the cladding system following typical conventional the curtain system, you better to think about these kind of modular system you design to make your facade a more volumetric way. So let's look at the glass ingredient. Glass is made from sand, soda ash, sodium, lime, alumina, and potassium oxide. So it has various thickness from 3/32 inches to the 1 inches. And you also remember when you're having a stronger glass, you're using the lamination glass. So this kind of Apple store everything made by glass. The glass column, glass beam, glass exterior cladding. The one single cladding system is not support itself. It cannot support the weight. That's why you have to be consider this single cladding system as lamination to making the stronger glass. So that's why you have to be think about which single glass you have to be used and how you're laminating together, how many layers you have to be laminating to support a certain weight. So if glass is treated by heat, you also remember it is tempered glass. The glass will be much stronger glass, so you can call the tempering impact glass. So you remember about this project, we talk about this is a tempered glass, but also laminating together, which is a lamination glass, to make this structural quality glass produced from the factory to making this project. Let's look at the glazing assemblies on incoming sunlight. So there is a three typical type, which is a clear float glass, refractive glass, and double glazing system. You see the clear, refractive, double glazing system. So as you see the diagram, most incoming sunlight is transmitted into the interior space, right? And however, if you have a refracted coating or you have a low E coating, this is a transparent coating, but it starts to reflect the sun from the surface, outside surface, and less of a heat light will pass into the inside. And also, when you're having these refracted film, which is low E film, you can reduce the heat energy from outside, and also the glass thickness start absorb more heat energy. So that's why you can just protect the intense sun energy from outside to making your interior space more comfort the temperature. And at the double glazing system, it is most energy efficient type. Of course, you can make in a triple glazing system and more than this. And most sunlight reflected by outer layer, because when you have a low E, the when you reflect in outer layer, having the reflecting coating, and then rest of heat light is captured into this air space. Try to make this air space. Sometimes you can you can put the argon gas. So this vacuum space try to absorb this sun energy. You remember, air space is the most effective insulation material. So therefore, in the same concept, this vacuum space try to absorb this sun energy as well, and it works as insulation. Okay, so therefore you can think about when you're having to construct about the thermal performance and try to construct about the more effective U value, you have to be considered to using the double grading system and triple grading system. But these days, triple grading system also pretty popular, especially in pretty severe weather like Iowa. But depending on the budget, you can choose either double grading system and triple grading system. So when you consider double glazing or triple glazing system, we have to be consider two technique, which is insulated glazing, IGU, yes, IGU, and low emissivity coated glass, which is a low E, we talk about it. IGU, it is most common type in double glazing or triple glazing system, and it is double or triple glass window panel separated by gas filled or vacuum filled space to reduce heat transfer. The glass panel are separated by spacer. This is a spacer. This is the most important technique when manufacturing the design IGU. The spacer system helps to create effective thermal barrier at the edge of IGU. So this one having this desiccant, which is to absorb humidity and two, making this space more vacuum and dry. Okay, so it is mean increase the thermal value. Okay, so therefore they having these spacer, the bottom and top, to seal this space as the vacuum space. Sometimes you can injecting argon gas to increase these thermal performance better. Okay, but mostly we can actually just keeping as the vacuum space. The low E glass, it has the super thin transparent coating. It is much thinner than human hair, so but it reflects heat energy. Okay, it reflects the direct heat energy from outside, but it also keeping the thermal energy from the inside. So mean when you're having this low E coating from the exterior surface, you can increase the thermal performance a lot from these two different techniques from the window frame system. So just kind of reminding about the window frame to use select. So have to be considered the double glazing and triple glazing system having IGU, which is the spacer to making the high perform vacuum space, and you have to be having the low E glass outside, which is to protect the direct thermal energy and protect the thermal energy from the inside, so improve thermal performance from the window glazing layers. When you're understanding about this, you can see this is a different glazing type: single glazing system, double glazing system, low E glass, and also double glazing system with a low E argon. And so you can see all different information. So this is a double glazing system, argon gas fill, and low E glass. So and then you can see U value and R value. You remember R value is resistance value, higher R value is the better thermal performance, and lower U value is the better resistance performance. So let's look at some comparing between the single glazing system. For example, it is the 1.1, 1.0 U value, 1.0 R value. But when you're having the double glazing system, it's hard to see, I can zoom in. The double glazing system here, and low E glass, so U value and R value is 4 times better performance, which is a 4 times better performance for R value, but U value, which is the 0.25, but 1.5 of 1/4, which is a 4 times better, okay, performance for your glass. So therefore, you can even think about easy to find the performance from each glazing type. And also when you compare the VT, the visible light transmittance, which is the ratio of visible light passing to amount striking the glass. So most lighting passing through the single glazing system, but here only 71% the transmit the light. So that's why you can block the glaring from the outside. And even you can just see solar heat gain. Of course, this is much less the solar heat gain from outside, and of course the more lighting coming from single glazing system, so you can see there are more UV light passing through compared to this. So that's why protecting UV light, protecting the direct sunlight, and then also the protect the solar heat gain, so mean the double glazing system with the low E, the gas fill. So that is much better, 4 times better performance compared to the single glazing system. So you understanding about how you understanding about this kind of glazing performance, how you decide and how you propose for your cladding system. Okay. So and then when you have all your glass product from the manufacturer, so they provide this kind of label, and from this label you will understanding about what each number, what each the word means. So because the VRT, which is the visible light transmittance, SC, the shading coefficients, SHGC, solar heat gain coefficient, U value. So you can simply finding from the previous the table, you're understanding about these all the means, and the two making this glazing system, they have some dual seal silicone. This is a first layer. They're using the 1/4" solar bond 60 C2 annealed glass. Outside, inside they're using the clear annealed glass. In between, they have a 1/2" millimeter spacer. So this is a double glazing system. You probably understanding very well. So it uses the 1/4" low E annealed light outside. So this is outside using this layer. And then using the spacer and seal, and to making the vacuum space, it is 1/2". And inside using the 1/4", the clear annealed glass. So this is about how they design the glass. Of course, you have to add the framing to designing the window frame. So when you're having these glass ingredient and combination, you can also see the performance. VLT is a 0.7, SC is 0.44, SHGC is 0.38, U value is 0.29. It's pretty good, the glass performance. So you just gonna every single time you gonna see this kind of level, then you understanding how you read and how you understanding about the performance of this kind of glass product. Let's talk about the cladding requirement. When you design a cladding, what you have to be considered. Let's talk about the cladding requirement. This is a primary function of cladding. So of course, your cladding has to be keeping water out, to prevent water leakage from rain, snow, and ice. The water problem are more issue in a tall building, so that's why you have to be provide the proper water protection strategy from your assemblage and from your materiality. And of course, you have to be preventing air leakage from your cladding, prevent unintended passage of air between indoor and outdoor. Air leakage waste the conditioned air, so it means losing the loss of energy through this gap. That's why you have to be sealed tightly between the frame and glass, between the window frame and floor and wall assemblage. So we talk about this assemblage already from our section detail, but we're gonna talk about the protection one more time from 4450 class. And of course, your primary function of cladding, you have to be controlling the light. It is control the sunlight to balance between useful illumination and unnecessary effects such as glare and fading of material. If you think about this kind of design, lots of direct sun coming, and then your furniture and material start to fade. That's why you have to be considered to protect this kind of direct sunlight from your design. And also another primary function of cladding has to be controlling the radiation of heat. Interior surface can cause discomfort due to the radiant heat transfer during the summertime. In this case, it needs shading device. We already talked this shading device from Tuesday lecture. And also thermal insulation. You have to think about low E coating outside, right? And double and triple grading system, and adding the spacer to making the vacuum space, and also injecting the argon gas to increase this thermal performance value. Okay. And then also you have to consider proper glass uses to control this latent heat. Also you have to be remember about the summer sun and winter sun. The winter sun, we better to bring this winter sun in, because to make the winter is kind of usually cold. So I mean, how we bring this thermal energy from the outside. That's why you better to bring the winter sun from during the winter season. But summer season, the summer sun is higher, but this sun is better to protect because it usually transfer lots of heat energy and try to make it more comfort the temperature from inside. You always consider to block the higher sun, which is the summer sun, but bring this lower sun. This is a winter sun. So mean to keeping the sun temperature the more comfort level. And next one, you have to be also controlling conduction of heat. I think conduction is the main things to make the condensation, you remember, right? So mean window frame, sometimes when you're using the aluminum frame, there were lots of conduction happening when you're having a different temperature inside and outside. Of course, you're losing lots of thermal energy, but you start to also see the condensation from this kind of a surface. That's why when you're designing the cladding, you have to be considered about the controlling about the conduction of heat. heat conduction is the heat movement between material having different temperature requires to using the, so when you protecting this kind of transfer, you have to be provide insulation to resist the conduction of heat into in and out of the building. Of course, you can also provide the vapor barrier too. And also we highly recommend using the exterior resident insulation to the balance temperature inside and outside to block this heat transfer between the inside and outside of the building. Also, architect also required to consider sound control, which is acoustic, is important. So we usually provide the double glazing glass type and insulation and some finish wall and or sometimes interior wall to enhance the sound control from your design. Okay. And this is a secondary function of cladding. The first, depending on your project location, you have to be considered resisting wind forces. The cladding requires to apply adequate strength, stiffness to sustain pressure by wind. Wind pressure will vary by height and the location. You see this is higher wind pressure and lower wind pressure. Depending on this wind pressure, you have to be provide the different window frame type you have to use and different window size you have to be consider, and also the higher pressure of course have to be given the deeper window frame, right, to hold this window, the panel tightly from from your exterior design to resisting these high wind forces. And next one, you have to be consider the control water vapor. So water vapor is occurred by possible condensation. You already talked about it, right? So this one happening from the conduction, the main reason to making the condensation, but it can cause loss of insulating value, metal corrosion, wood decaying. Also, you can see the mold from the surface. That's why you have to be considering about controlling the water vapor. And movement is important. When you design a building, so movement is thermal expansion and contraction. You remember why we provide expansion joint from the building, the brick or stone creating system, because the building keep moving this horizontal way, and the materials have to keep expanding and shrink. So therefore, when you don't considering about these kind of building movement or the wind movement, your building start to see the crack or some failure of your structure or cladding system. And also your movement can consider about the moisture expansion and contraction. So this is a kind of part of this kind of a building movement issue. So when you're having this kind of movement for cladding design, this is considering about the structural movement. We have to be consider the building foundation and column shortening, which is typically occurred in high-rise building, lateral forces such as wind, earthquake forces. This structure failure occur many trouble at the exterior, especially you easy to see the crack from this happening. So think about this is a building. So building is heavy. That's why this keep impacting to as the gravity. So you see the column shortening. So therefore, we have to be provide proper the column thickness and column size basically from the building height and building weight. And of course, you have to be think about the lateral forces happening like earthquake or like a wind forces. So in this case, you have to provide a certain expansion joint and certain gap between the window frame and the cladding design, or window frame and wall assemblage have to provide some tolerance space to protecting this movement. Okay. So therefore, we have to be considering about the building movement, basically from the lateral forces, gravity, also sometimes considering about the air movement from your design. Okay? So this kind of work, the structure movement, the wheel making some result in broken glass and sometimes cylinder failure and broken cladding attachment, failure of the whole wall system. So that's why you start to have to be considering about this structure movement from your cladding design. Okay. Let's talk about the water tightness in a cladding. We talk about that this is the main thing you have to be considered when you design any cladding design. So how we protect water from your cladding design. So when you have any kind of cladding design, we have to be consider water has to be kept away from our cladding system. So what is the major concern about the water penetration? We need to consider opening. So opening can be eliminated by carefully sealing every possible joint. And forces are always present, such as gravity, wind forces like lateral forces. So these forces keep delivering water from outside to the inside. So we can say coming to here, right? So this is the exterior, the fiberglass mesh sheeting. But of course, you can just protect in the water. But water just coming in, water have to be dropping down right away. To protect the forces, we need to proper the weather barrier over sheeting. We have to provide waterproofing membrane here, and also have to provide cavity space, which is the ventilating air to dry out these kind of water as much as possible. Okay, so let's look at the possible forces type on your building and show how we can protect the water from the exterior side. First, we have to care about the gravity. So when you design the wall panel joint, you have to consider water flow through gravity. So when you're designing about this kind of panel, this is a lower and higher. The water is dropping from here as gravity. Of course, the water coming to interior space. So, but as we learning about water have to be getting out of our assemblage as much as possible. That's why rather than placing this much lower, you can consider about outside can be better to be lower. So I mean when water coming in and the gravity from the gravity is not coming into this assemblage, water coming out again from this assemblage. So therefore it is the panel plane constraint incline the slope inward when you have a joint panel. Okay, so that is more to consider about your panel design rather than these conditions. Okay, the next one is momentum. The momentum is also considered force when you design the cladding. When panel is the flat, then water get into interior space by momentum forces. When water coming in and touching it and refracting to the other side, it is called the momentum. So therefore, when you design the cladding system, you have to be considered to provide these kind of dam, which we can call the Leverance joint. Then means when water touching it and is protecting it and coming back. So that's why it is considered rather than totally flat surface, you have to be considering about these Leverance joint to protect these momentum forces. And surface tension. Surface tension, water tends to stay on surface because of the tension. So when your water's gravity down, the water tends to stay if you have a flat, the water tends to sting over the surface because of the tensional forces. So when you the tensional forces, water coming down through the gravity and tensional forces and water delivering into the disassemblage. That's why you have to stop the water. So I mean we can talk about it is water stop. So even when you design a concrete slab, and if you have your glasses here, window frames here, and this is exposed concrete, you always have to provide this water stop, because when water coming and tension here, and if you doesn't have any water stop, if you water stop, the water coming down from here, but if you don't have a water stop, water tended coming into your assemblage because it has some tension to delivering water into your assemblage. That's why you have to provide this water stop from cladding or any exposed concrete slab. Okay. And also capillary action. If you have a very tiny gap here, the water will infiltrate inside of space because of capillary action. Capillary action means if you have a certain amount of air, this large amount of the air, and then this is a small amount of air. So mean the water air keep pushing into these smaller gap. It is called capillary action. So mean air forces coming from outside and inside is kind of high pressure, and if you have water here, the water simply delivering into this assemblage. That's why you have to provide the counteracting forces here. So I mean this is a large amount of air keep pushing into this small gap, and you also making another the air amount, and it means it keep pushing another air from the inside to the outside. So it means you can actually making this neutral design. So water coming, the air coming from outside inside, another air coming from inside and outside, which is this inside and outside inside, they fighting each other and neutralizing the air forces. That's why the air not coming into this assemblage. So mean water not coming into this place. So therefore, when you're designing about your cladding, even you also have to be considering about this capillary action to making another cavity space from inside to pushing the air from inside to the outside to protecting the water. And of course, think about when you're having these kind of consideration, now you have to be concerned about air pressure difference here. Air pressure is one of the difficult to deal with designing the water tightness, because wind pressure on the outside keep driving air and water into the wall. So, but when you're having designing the pressure equalizer chamber, which is the PEC, so this is a kind of a channel, it's like a channel design. This channel design to hold in these kind of the cladding panel. So this the channel location is horizontally and vertically to sorry, this is a connecting here to connect and to hold this kind of cladding system here. Okay, so when you're having this four cladding system, for example, this four cladding panel, or when you see that this PEC, the locating the X and Y direction. So this is location here, location here, location here, and location here to hold this panel, also to making the counteracting forces. You remember about the capillary action, air keep pushing in, but you need to making another counteracting forces here. So another air coming from inside to the outside, which is to the balance the air, equalizing the air. So that's why air not pushing into the space. So therefore, air never coming into this interior space. When you're having the PEC channel to holding this cladding system, then it is kind of holding the cladding system and also the provide counteracting forces from the inside. Okay? So you can easy to see that this PEC system here. So it's the PEC channel hold the Y direction and X direction to hold this exterior cladding panel, but also provide the counteracting forces from inside to the outside, and it actually protecting the air movement or capillary action from outside and neutralizing this space. That's why water not delivering to the interior space. It is called PEC, so pressure equalization chamber. But also we talk about the different forces like a tension, gravity, capillary action, right? And basically to consider about these kind of forces, we have to be considering about the Leverance joint, which is a Leverance joint. The Leverance joint is here. This is the panel on the top, and another panel is connection like that. So mean when water coming from here, actually consider about the gravity, the water never coming in because the outside is lower than inside. And next one is about the tension. When water coming here and water staying over the surface, but we actually making the water stop, so mean water not coming into the space and this water get out of this kind of assemblage system. Next one, you have to be consider about the momentum. So you remember the momentum we actually provide like this system here. And then when water touching it and the refracting, which is a momentum, protecting this water refraction from this dam. So I mean when water coming down and refraction, you actually protecting the water from this dam and then redirect the water and out of the water from this assemblage. So therefore think about when you're designing any kind of exterior cladding system, the lane screen system, you remember about the two different cladding system. Number one is a Leverance joint to concern about gravity, momentum, and tension. So these things you have to be considered and to design the Leverance joint to protecting the water delivered from outside very well. And when you consider about the Leverance joint with the pressure equalized chamber, which is PEC, is more relating to the capillary action. Actually, it's a more amount of air from outside and small amount. You keep pressing this air amount to the inside. You actually making the counteracting forces from inside to utilizing the air amount and air pressure to protecting the air delivered from outside. So think about the Leverance joint, which is considered about the gravity, momentum, and tension. And PEC is more considered about the capillary action to making another counteracting forces from the inside. Okay. So this both case is kind of great to protecting the water delivering from your outside. I think that is super important part you have to be remember for your project, because without this consideration, the water keep delivering from outside inside. It means your assemblage keep the weight. So that's why even it keep ventilating the air. Sometimes it is little more than the dry, sometimes humid. So that's why you have to be think about the protecting the water as much as possible from your cladding system, the considering from the Leverance joint and PEC to pressure equalized chamber. Then you the first layer to protecting the water and air. Then you making another cavity space. Still to provide this kind of ventilation through the layer. Okay. So this is also say we talk about the lane screen system. rain screen cladding, you have to remember one thing. We already talked about the rain screen sensor a lot. Gypsum board, the framing, insulation, fiberglass mesh sheeting, rigid insulation outside, and waterproof membrane. And we have to provide these open cavity space, but these rain screen system have to provide 1 inch to the 2 inch gap, because we have to provide enough space to ventilating the air to dry out the water. So first layer for your cladding system assemblage have to be considered the PEC and leverance joint. And for the cavity space, which is we can call rain screen system, which is providing the cavity space, have to provide 1 inch to 2 inch spacing to ventilating the air to dry out the water from your assemblage. Okay. I think I just gonna bring the one video. I think this is a kind of pretty well explaining about the rain screen. So let's watching this kind of video together.
When it comes to designing high-performance buildings, you must be adamant about moisture control. Waterway, rain screen and ventilation mats give your wall systems countless performance advantages. Advantage 1. Drainage. Waterway rain screen is installed between your building and its exterior cladding. It features an advanced filter fabric and polypropylene drainage core. Waterway creates a capillary break and space for water drainage, allowing it to mitigate moisture penetration. Advantage 2. Ventilation. Our rain screens also provide continuous ventilation by convection or stack effect. As the wall heats up, warm moist air rises and escapes out the top, while cool dry air is introduced at the bottom. This cyclic ventilation dissipates moisture, keeping your building dry. Advantage 3. Open drainage path. Chambered configurations like the furred wall shown on the left can only provide drainage and ventilation within a confined space. Waterway's 95% open area ensures a clear space for multi-directional drainage and drying. Advantage 4. Moisture protection. Our unique filter fabric functions like an extra layer of house wrap. It is fully tested to prevent water penetration from the outside, keeping your building dry on the inside. Advantage 5. Backside drying. The perm rating of our fabric exceeds 200. This means it promotes the backside drying of your exterior materials. Moisture in the facade is allowed to evaporate through the filter fabric, allowing the wall to dry from the inside. Advantage number 6. Flat walls. Typical rain screen products are not able to resist point load from siding attachment, resulting in a wavy siding surface. Waterway's robust fabric distributes point load during siding attachment, resulting in a flat, uniform surface. Advantage number 7. Retained space. All rain screen products look like they're providing a consistent drainage space behind the claddings. The truth is they cannot hold up to the normal stresses from siding installations. Once nails, screws, or other forces are applied, they compress substantially, compromising the drainage space. The advanced geometric configuration of our polypropylene core results in the industry's most rigid material. This ensures the drainage space is maintained across your wall. Advantage number 8. Uniform thickness. Waterway contributes to uniform thickness in your scratch and brown coats, unlike furred or strapping systems. Variations in stucco thickness can often result in very thin areas, which are prone to vertical cracking. This is never the case with Waterway. Advantage number 9. Cushion. While on the topic of stucco, Waterway's flexible core also functions as a cushion between your building and exterior facade, reducing stress due to thermal movement or settlement. Waterway is proven to reduce cracking in stucco and stone veneer systems. Advantage number 10. Validation. The Building Research Association of New Zealand conducted an 8-year study on numerous rain screen materials and configurations. Only the Waterway product performing rain screen mat.
So to conclude today's lecture, I would like to reflect on a tragic real-world example caused by failure in rain screen creating design and construction. This incident occurred at apartment building balcony near the Berkeley campus, where 6 students lost their lives after 5th floor balcony collapsed. So why and how did this construction fail? First, the structure system of balcony was not designing for support load of 6 people together. So, but that people, like the college kids, actually drunken and they actually standing over. This is number one reason. Second, and more critically, the wall and balcony assemblage didn't provide sufficient cavity space between the structure component and exterior finish. So mean doesn't have any cavity space. It doesn't have any kind of dried air and a dried kind of this kind of moisture and water between the structure and finished material. As a result, water and moisture became trapped within the assemblage. Without proper ventilation, the moisture couldn't escape or dry out. Over time, this led to severe decay of the timber structure and member. You see the image here. This is some decayed the structure here. The continuous exposure to the moisture weakened the structure, ultimately causing the tragedy. As we discussed today, a properly designed rain screen system must include a cavity that allows for air movement, enable moisture to drain and evaporate. Without this, even well-designed athletic facade can conceal serious structural risk. I would like to emphasize this point. So when you design your project in the future, athletics are important, but they must always supported by strong understanding of building performance, technical detailing, and safety. So design is not only about what you see, but also about how a building performs over time and how it protects human life. So therefore, we talk about how we protecting water from the cladding system, and how we design the labyrinth design, how we design the PEC system, and why it works and how it works. And also, we have to provide the rain screen system. Rain screen system gives cavity space between cladding and the fiberglass mesh sheeting, because to provide the 1-inch, 2-inch spacing to ventilating the air to dry out all the moisture and water. So please keep in mind this is a kind of important, of course, design, but of course our safety from your assemblage. Thank you guys for today's lecture, and after this lecture, please keep continuing your lab today. Thank you guys.